Hey guys, this is a little bit of homework help for 14.5. I know that you get into it, there's going to be issues and questions that come up. So I'm just going to go through a handful of them and maybe talk about some special cases and things along those lines. So the basic premise is that, multiplication division can happen inside of a square root, or it can be separated in a square root. On a problem like question number 8, okay, if we look at this one, we can multiply the 5 by the 3 because they're on the outside of the root. And we can multiply the 24 by the 10 because they're on the inside of the root. So number 8, our question really is 15 root 240. Now, that would maybe be okay if we believed that 240 didn't reduce as a square root. But if it reduces at all, we need to try and reduce it. And so that's 15. Let's not forget about it. It's going to kind of creep down with us. We're not going to worry about it, but we're worried about this 240 pretty extensively. If we think about splitting the 240, the first thing that I think of that goes into it would be 4 and 60, because I'm thinking of 24. And so I think 4 and 6, and so I get 4 and 60. Now 4 does have a square root, but I need to make sure that there's not a better option or better combination. And so I keep coming. The big question is there another 4? Turns out there is. 4 does still go into 60 15 times. Now if I'm looking at that 15, okay, I see that I've got 3 and 5. Now technically the 4s do break down. I don't want to misguide you. The 4s do break down. However, because they match, I actually don't want to break them down. Remember that when you're doing square roots, if you can write a square root with 2 multiplied numbers that are identical, that means that number can come out of the square root. You can also think of this as the square root of 16. That's something we can evaluate. What we can't evaluate is the square root of 3 times 5. I don't know what 3 times 5 is going to break down as a square root because they're not identical. And so here I have a 15. This square root, whether you're talking about the square root of 16 or you're talking about this root of 4 times 4, it produces a regular out of the root 4. The square root of 4 times 4 is 4. The square root of 16 is 4. And over here we still have a root 15 left over that we couldn't do anything with. Where people start to struggle a little bit is what math goes between all these numbers. There was no mathematical symbol between the 15 and the root 240. The implication is that it is a multiplication. So this is all multiplication. Remember, we can multiply outside stuff, we can multiply inside stuff, but we can't do outside-inside. Now that the 4 is on the outside of the root, we can multiply 15 by 4 to get 60, and we have our leftover root 15. That is our simplified version for number 8. Let's jump down and look at question number 12. All right, number 12 has 7 over the square root of 12. Now the rule that we talked about last time was that, or as we talked about in class, was, hey, we can multiply top and bottom by root 12 to get the root out of the bottom. We're not supposed to leave a square root in the denominator. But if the 12 breaks down, then I don't need to move it. You look at questions like number 9. Do I need to move that 16? Or do I just need to say the square root of 16 is 4 and that that's no longer going to be in the square root? So when I look at this, I want to see how the 12 breaks down. I know it breaks down as 3 and 4, but the 4 breaks down as 2 and 2. So this could be written as 7 over the square root of 4 times the square root of 3. The reason that matters is I know the square root of 4 is 2. So this would be 7 over 2 root 3. Now, I still have this issue that I have a square root in the denominator, but the square root is now smaller. I'm only dealing with the root 3 that's a problem, not the root 12. So if I multiply top and bottom by the same value, specifically root 3, I should be able to get 7 root 3 over 2 times the square root of 9. But I know the square root of 9 is 3, and 2 times 3 is 6. So 7 root 3 all over 6 is my simplified version. Let's look at one of these that needs a little bit of work. Let's look at 16. It's a little bit more challenging because there's some addition and subtraction in the denominator. So I've got 1 over 5 plus root 6. This is that set where we talked about using the conjugate, its special partner. If I have 5 plus root 6, I need 5 minus root 6. And if I use that on top and bottom, the top's always pretty easy. It's a straight distribution. In this case, we actually just get 5 minus root 6. On the bottom, because it's a conjugate, I only have to multiply the F and the L of FOIL. The other two terms, the O and the I, would cancel each other out. Well, 5 times 5 is 25. I know I'm going to get a negative. This will always come out as minus. The square root of 6 times the square root of 6 is the square root of 36, which we know is just the number 6. We still need to subtract the denominator to finish. We have 5 minus root 6 over 25 minus 6 is 19. And there we go. As we jump to the second part of the assignment, where we're no longer working on just simplifying, we're working on actually solving equations, we have to recognize something unique about these problems. These are not the same as what we did in the factoring sections, specifically because the variable only shows up once in every question. Even this one down here, 32, it only shows up the one time. So as we go through these, keep that in mind, that not all the problems are the same. That these have this uniqueness that they are able to have that not every problem has. Let's take a look at number 26 to start. And we have one little thing that if we didn't talk about in class, I'm going to bring up here as we solve these problems using square roots. It's really important. 4p squared equals 448. I want to isolate this p. And in class we talked about solving using SADMAP, which means we use order of operations backwards when we are solving. Okay, this is to solve. So I want to do any addition subtraction, which there is none. Then I want to do any multiplication division. I see this times 4, so I will divide by 4. It's important we do that before we get into the exponents. That gives me p squared equals 112. And now I'm going to take the square root. This is the big key. Whenever you or I put a square root into a problem, we have to acknowledge one thing. Quadratics are symmetric. What that means is that if I want to know, if I look at x squared, say minus 9 equals 0, and I want to know when does this equal 0, if I add 9, I'd get x squared equals 9. I take a square root, and most people in the world will say 3. But if I were to actually graph x squared minus 9, down here at negative 9, I'd be set up there. Okay, sorry. So we're at this square root, right? So if we graph x squared minus 9, it has a right side, and it crosses right there at 3. We have to acknowledge that it has a left side, and it crosses over here at negative 3. What that tells me is that it isn't just 3. It's positive or negative 3. Now the question is, how do I know when I'm supposed to use positive or negative? The answer is that whenever you put a square root into a problem, if you or I were the author of the square root, we're responsible for putting a plus or minus in front of it. So our answer is going to be p equals plus or minus the square root of 112. But if 112 reduces as a root, we need to reduce that. Now keep in mind, if it reduces, all of this is part of this square root, it's going to stay on the right side or stay behind the square root. So as we break this down, I actually don't know how this splits, but I really have a sense that 4 is going to go in. 4 goes into 125 times. 12 goes into 12 3 times. That would be like 28, which this would split again as 4 and 7. So I really like that I have two 4s. So I'm thinking of p as plus or minus the square root of 4 times 4 is 16 times the square root of 7. But I know the square root of 16 is 4. So this would be plus or minus 4 root 7. Notice that 4, it's not going to get in front of the plus or minus. It stays behind that plus or minus and hangs out with the 7. Really important we keep those together. So here we actually get 2 answers instead of 1. Let's take a look at question number 32 to finish off. Just want to make sure that we're really clear about this process. We have 32, 7 times x minus 4 squared minus 18 equals 10. So the first thing that we're going to do, get some color in here. First thing we're going to do is go through, again, SADMAP. Is there any addition or subtraction I can do? Well, I can add 18 to both sides. That's going to produce 7 times x minus 4 squared equals 28. Now I'm looking for any multiplication or division before I get to exponents and parentheses. So I'm going to divide by 7, divide by 7. That gives me x minus 4 quantity squared equals 4. Right here, I'm going to go ahead and take the square root. And remember, when we put a square root in, we put a plus or minus with it. That would give me x minus 4 equals plus or minus. Now, oftentimes we leave a root here, but we actually know the square root of 4 turns out to be 2. To finish getting x alone, I need to move this 4. I'm going to add the 4. And the way I write my answer is very particular. We're going to write it as x equals, we keep this 4 that we just moved. It's going to be the first thing in our equation. Then we put the plus or minus, and then we put the square root. Now, normally there's some sort of a square root here. Maybe this would be root 7, and we'd have 4 plus or minus root 7. That's typically how it's done. This is a problem where actually the answer does come out as a whole number. And if that happens, anytime that happens, we do know how to add, we do know how to subtract. So we should answer, what is 4 plus 2? That tells me that x is going to be 6. And what is 4 minus 2? And 2. And those would be our 2 answers. Typically, we're not going to see that. If it had been done that way from the beginning, we probably would have factored it or done it some other method if we'd known that the answers were going to come out as whole numbers. Hopefully that helps you with your homework and gets you far enough along to be able to ask some good questions when you come into class. Good luck, and we'll see you then.